Okay, if you're copying by hand in Zoom, just copy the method 1 section for right now. Don't copy method 2. I'll give you some time to copy that when we get there, okay? All right, those of you who are in class, you ready to begin? Bring your attention, center, focus. We're going to do math for not very long, just a little bit. So our goal today is to write equations of lines. What we have been doing is graphing from equations. Oh, I'm not displaying it. I'm sorry. Okay. What we have been doing is we're given an equation and we graph it. And now we're going to do the opposite. We're going to be given some information and we're going to use it to write the equation. What does the code say, Hayden? Please.
Oh, it's 4352.
4352. Thank you. And we have 3 methods, okay? So the first, I'm just making up stuff. The first method is slope and y-intercept. So this, we already recognize as slope-intercept form, right? We graphed some lines using this form last week. This is the easiest method of all. You're literally just plugging in stuff. So it's the example says, find the equation of a line with slope -9 and y-intercept -4. Well, the slope is your m, and the b is the -9 from this point, or sorry, the -4. And so you just plug that in. So it's y equals -9x minus 4. It's like not even, it's almost embarrassing to do this problem. It doesn't require any hardly thinking at all. But we'll be making up for that in just a moment. So our m equals slope, or -9. B is -4, and we just plug it in. The next method, and we solved this form of an equation last week when we were graphing, is the slope point form. So I'll give Zoom, if you're copying by hand, I'll give you a moment to copy this down before I talk about it. Yeah, I'm going to call out my in-person attendance because I know I'm missing someone. I have Austin, Jaden, Ozzy, Kayla, Cassandra, Avery, Ashley, Angel, Hayden. Who did I miss? Did I miss anyone? No. Okay. I feel like I did. All right. So for this example, this is, you'll have a problem. You'll be given the slope. So here we have m equals -1/3. And then you're given a point that the line contains. Notice there's no 0 in that point, right? It's not an intercept. Those are special kinds of points. This is just a random point, 6, -4. And we want to write the equation in slope-intercept form. So a couple things going on here. What are you missing? Oh, okay, bless you. So if you're given the slope and a point, you know you're going to be using this formula to figure out your answer. But it doesn't stop at just plugging the information in. So please notice the sentence here says, write the equation in slope-intercept form. So our final answer has to look like this. Okay, so we're going to plug into the formula and then solve for y so that it looks like mx plus b. So the plugging in part's pretty easy. The 6, -4, this is your x1 and your y1, which is going to go into that formula. So I'm going to take this thing and just plug stuff in. The y is going to stay y. So I have y minus y1. So my y1 is -4. Okay, so I'm subtracting. This minus that I have written down comes from the formula. This minus that I'm writing down next comes from the -4. So the first negative from the formula, the second negative is from the point. And then I plug -1/3 in for m, parentheses x minus whatever x1 is, which is 6. So yes, it's fine, I've plugged stuff in, but it's not the final answer for the problem. So I have some math I have to do. I need to get this solved for y, and here's how we are going to do that. On the left-hand side, I'm going to rewrite minus a negative as a plus plus, or y plus 4. And on the right-hand side, I'm going to distribute the -1/3. So that gives me -1/3 x. And then let's talk over here on the side about distributing the -1/3 times the -6. So the first thing is that negative times negative is going to give me a positive number, right? And then the second thing is when you're multiplying fractions, you go across the top, which gives me +6, and across the bottom. But what do I mean here when I say across the bottom? Because -6 doesn't have anything on the bottom. It's over 1, right? So now when you multiply across the denominators on the bottom, it's 3 times 1, which is 3. And 6 divided by 3 is 2. So that was just some work I did on the side. So now I'm going back to the problem and putting +2 here. So I'm a little bit closer to y equals mx plus b. The problem is that there's still a +4 with the y on the left. What do I do with that +4 to get it over? Subtract it from both sides. So I've got y equals -1/3 x minus 2. So this second method again is for when you're given the slope and a random point. The first method was when you were given the slope and a very specific point, which was the y-intercept. So let's make a note about that. For method 1, this is what you were given. You had slope, y-intercept. The second one, you had slope and just some point. Well, I guess I already put that with the method 1 and the method 2. Sorry, did you see how I thought that was important? And it's the exact information I already gave you right here. I guess you can't, it doesn't hurt to repeat it. And this last method is for when you're given 2 random points on the line, okay? You don't have the slope yet, and it's not a y-intercept point. So your job is to use the 2 points to find a slope Once you have that information, you can go back and start with method 2. So it's like this method is just layered up from the previous one. So what we have are my 2 points, -3. Actually, if you're in Zoom, I'll shut up for a second and let you just write this down. If you're in Zoom, write down this new section while I continue to not talk, starting now. Okay, I feel like that was enough time in Zoom. Zoom, if you need more time, could you just unmute yourself and tell me real fast, please?
I'm good.
You're good. Okay, thank you. Thank you. All right, so this method doesn't give us a slope. We use the 2 points to find the slope, and then when we do, we come back and we switch over to method 2, which is what we use when we do have a slope. All right, so here's the first step. Find the slope. And you'll notice I gave you the slope formula here. You subtract the y's on top. It's the difference of the y's over the difference in the x's, or maybe you've heard that before as the change in y's over the change in x. So we are going to label our points. This first point I'm going to label x1, y1, and the second point x2, y2. And then the slope will be where we subtract the y's on top, y2 minus y1. So that will give me -2 minus y1, which is -1. And then subtract the x's on the bottom in the same order, like it has to be 0.2 minus 0.1 for the y's and 0.2 minus 0.1 on the bottom. So that will give me x2, which is 2, minus x1, which is -3. Both of those happen to have minus and negative in the middle. That changes to plus plus, right? So on the top, that gives me -2 plus 1, which is -1. And on the bottom, I have 2 plus 3, which is 5. So now that I have the slope, I'm going to switch back over to method 2. So I'm going to plug slope and 1 point into this formula for method 2. Plug the slope and one of the points into that formula, which we just talked about in method 2. Do y'all sometimes just think math is awful? Like, when are you ever going to use it? When you go to college? I sometimes feel bad for y'all. What does it kill you, make you stronger? Math makes you stronger. Mental fortitude or something like that. So when we go plug stuff into this formula, the slope, the m is going to be -1/5, but the x1, y1 part, it can match the x1, y1 that we had in the original problem. Like it could be this one, or it could be the other one. Like it doesn't matter. As long as your math is good, you'll get the same answer. I'm just going to use that highlighted point because it's convenient and it matches that I've already labeled it x1, y1. So that goes like this. So using that formula, y minus y1, which is -1, equals m, which is the slope that we found in step 1, -1/5, times x minus x1, which is our -3. And then our last step is to solve for y, because we want y equals mx plus b. So I'm going to do those pluses right where my two negatives are. And just like in the last problem, I'm going to distribute the slope into the parentheses. So right here. So my next step looks like y plus 1 equals -1/5 x. And the -1/5 times 3 is -3/5. Because you multiply across the top, which is the 1 times 3, and across the bottom, which is a 5 times 1. What do you feel like I have to do next? Because I'm trying to get y by itself. Subtract the 1. This one's a little bit different than the last one, though. I'm going to, so you see I have -3/5 and I have a -1 that I'm trying to combine with it. So let me go over here for a second, and we need to talk about adding fractions. So -3/5 minus 1. You can't combine numbers until they have common denominators. And so I need to rewrite that 1 as something with a denominator of 5. And we can rewrite 1 as 5/5, right? Because 5 over 5 simplifies to 1. If that's not something you remember doing or how to find a common denominator, let me just review this for you real fast. The 1 is really over 1. And in order to get that green 1 that I just wrote, in order to get it to match 5 in the other number, you multiply it by 5. But whatever you do to the bottom, you also have to do to the top. And then when you multiply across the numerators, you get 1 times 5, which is 5. And across the bottom, you get 1 times 5, which is 5. And then we have to talk about how to add fractions that have the same denominator. So you keep the denominator the same, and you do the math on the numerator. So -3 and -5 is -8/5. So we just reviewed finding a common denominator and then combining terms once they have it. So that's -8/5. So this problem kind of required a lot of reviewing of our basic math skills. Any questions about that problem? Okay, so that here endeth the lesson. Then you have a practice worksheet for that. I'm not taking any grades today, but I do highly recommend you do the practice worksheet so you get those processes down. And I do think this is a good time to remind you that we do have a semester exam. They're not being excused. And for math transitions, no, I don't know if they're doing exam exemptions this year or not, but math transitions is never allowed to exempt their exam. Because remember, this class is with them. It's a collaboration with UTSA